Hey there, everyone. We are ready to dive into our really first big set of hypothesis test sections. This is really the culmination of the course and everything that we have been learning about so far. And so this is the set of guided notes that we're going to look at from Chapter 10. And we actually cover three sections all at once here. Section 10.1 is a bit of a introduction, if you will, to hypothesis tests. And then we look at Section 2.4, which is hypothesis testing with means. And 10.4 is hypothesis testing with proportions. Okay, so what exactly is a hypothesis test? Well, what it allows us to do is sort of ask some questions and actually determine whether or not our particular claim or what we're interested in could possibly be true. And so it deals with sort of being a premise-driven or a little bit of a theory-driven approach. So let's take a look. So it says we've seen so far that if we suppose a certain value for a parameter p, we can compute the probability of getting a statistic which is so far away from the supposed value. So here's an example. So is the true proportion of all Wayne State students who applied elsewhere, if this is p equals 0.35, what is the probability that we get a sample p hat greater than 0.375? And what we did in Chapter 7 is we used our standard scores to actually get this probability. Now we want to discuss whether a given sample is even possible considering a parameter p or mu. Now, hypothesis testing itself, this is a procedure that enables us to choose between two hypotheses when we are uncertain about our measurements, that is, our statistics. So we try to have some sort of uniform standard for evaluating claims on the parameters. Now, a hypothesis itself is a theory or premise. Often it's a claim that someone is making that must be investigated. In any given one-year period, 9.5% of the population, or about 18.8 million Americans, suffer from a depressive illness. We generally use a hypothesis test to try and prove if these claims could be true. Now notice the wording here is could. What we need to really definitively say that it's true is some sort of an experiment. So hypothesis test doesn't prove things necessarily. What it suggests is that there is some sort of an anomaly that could potentially be occurring that has to be investigated a little bit more. Okay? All right, so we get into something called a significance test. So to begin any hypothesis test, we have to establish what are called the null and the alternative hypotheses. Okay, so that's a bit of a different set of vocabulary here. Now, it's very important, as you see this statement is bolded and underlined, is that the hypotheses are always statements made about the parameter, and the variables used have to reflect that. Now, since we're dealing with means and proportions, the variables that represent the parameters, remember, are p and mu. Therefore, those are the only variables that should appear in your hypothesis. Okay? So the definition, the null hypothesis, written as H, and then so it's a subscript that's like an O, okay, HO or H naught, is the conservative status quo statement about a population parameter. It often represents the no change, no effect, or no difference, and almost always carries the equal sign with it. Now, in the above example, when we're talking about Wayne State students, okay, the null hypothesis here would have been p equals 0.35. Because remember what they were saying is if the true proportion means the parameter is p equals 0.35, this would actually be the null. Now it says the alternative hypothesis, written as HA, okay, with A as a subscript, this is the research hypothesis. Sometimes we call it a test hypothesis. Okay, that's usually a name that we'll use, a test hypothesis. It's usually a statement about the value of a parameter that we hope to demonstrate is true given a sample statistic. This is the one that we always want to test the claim of. So you're going to see some wording a little bit later on where it says we want to test the claim that the proportion is more. That's going to be reflected in the alternative. Okay, so the first thing we have to do is understand the different forms that we can have for hypothesis. Okay, so we've got ones that are called one-sided or one-tailed. Okay, so there are actually two versions of them. So here they are. So here's the null, and here's the alternative. So this is the first version. Let's use P, and so let's say the first version here is going to be p is less than or equal to 0.35, suppose that's the null, then the alternative has to be p is greater than 0.35. So the null and the alternative are complements of one another, okay? Notice in the null we have equality. Did you hear me say it? P is less than or equal to, okay? The null always has the equal to. So that's the first case. The second case that's one-tailed is we've got the null and the alternative, and we're going to have p again and our good friend 0.35. What we're going to get here is instead of the null being less than or equal to, we're going to say it's greater than or equal to. That means the alternative has to be less than. Now, if you're wondering why is this one-tailed, the greater than that occurs here is actually an area right problem, and the less than here is actually an area left. And you'll understand that more when we actually do the hypothesis test, I promise. Okay? For now, when you see these inequalities, it means one-tailed. Now, the good news is we've only got one case for this idea of a two-tailed test, and here's what it looks like. It says p is equal to 0.35, and so the complement of that is not equal to. So if you see the not equal to, it's a two-tailed test. So it's the area in the tails. Okay, that's the idea. And again, that will be very clear when we take a look at the hypotheses later on. So what we've got here on the screen now, before we get to significance level, which is the next video, is let's practice actually establishing the hypotheses, okay? So what I'm going to do is work the first one with you, letter A, and then I would encourage you to pause the video and give B and C a shot. Okay, so letter A says, at Northwest Mississippi Community College, syllabi for online classes state that students should expect to spend 10 hours per week doing coursework for each 3-credit-hour course. The director of e-learning for the community college is concerned that students are being required to spend more than 10 hours per week doing work for each 3-credit course. Okay, so the first thing we have to understand is do we have a mean or a proportion? Because we have to make a decision of whether or not we're using p or mu. Now, because this number 10 is listed as hours per week, that actually is a rate which we interpret to be a mean. So in this case, we're using mu. Now the other thing here is if you're looking for proportions, remember you're looking for a fraction, decimal, or a percentage, and there aren't any listed. Okay, so we know 10 is going to be the magic number as well, because it's describing the parameter. Now, how do we know which is which? Well, they told us something. It says the director of e-learning for the college is concerned. What's he concerned about? That this students are spending more than 10 hours per week. Did everybody see that here? Okay, they're spending more than 10 hours per week. Since that's what we want to test, that's the alternative. Okay, remember that alternative is the testing hypothesis. So that's what we're interested in studying. So as a result, mu has to be greater than 10. Now, since the alternative is greater than 10, the null, has to be less than or equal to. It's the complement. So that's how we put together the hypotheses. So what I would encourage you to do is to try B and C. Okay, pause the video and give them a shot, and then we'll have a little conversation. Okay, so hopefully you have tried B and C. So let's take a look here. So we've got this guy in Switzerland who can hold his breath for, good grief, almost 20 minutes, 19 minutes, 21 seconds. That is crazy. Wow. Part of the found research suggests that adults can hold their breath, sorry about that typo there, breath for 30 seconds when submerged in lukewarm water. The other half of the group found evidence to suggest that the mean time is different if the water temperature is colder. So the group wants to test this claim about holding their breath in cold water. Okay, so we've established that we're dealing with means. Okay, very easy to see that. And the time that they're concerned with here is the 30 seconds. Okay, so now what exactly are they trying to test? Well, it says the group found evidence to suggest that the mean time is different. Okay, what does that mean? Well, that means it could be more or it could be less. So put another way, it's not equal to 30. And so if the alternative is not equal to 30, then that means that the null has to be. So this is a two-tailed test. Okay, good test question. I could ask you, give me the hypotheses, and then is it a one-tailed or a two-tailed test? And so that's easy to spot with the not equal to. Letter A was a one-tailed test, right? Just one inequality. Okay, and let's look at the last one here. This is a leading news agency claims that the president's job approval rating has dropped over the past 3 months. So previous polls put the president's approval rating at a minimum of 56%. The president's chief of staff's concerned about the news report since it's election year and wants to run a test on the claim. Now, since we're dealing with a percentage, this means we have a proportion. And 0.56 is our number in question here. Okay, so now the question is, what are we trying to test? Okay, well, it told us in the problem here that the president's chief of staff wants to run a claim. He wants to run a test on the claim. What claim? The claim about the news agency. And what they're saying is that the approval rating dropped. That means that the P is less than 0.56. That's what we want to test. Remember, the alternative is always the testing hypothesis. And so if that is less than, that means the null has to be the complement, which is greater than or equal to. And this also is a one-tailed test. So that's how this works in setting up the hypotheses. This is always the first step to the process. Now what comes next is a little bit more computation, but before we get to that, we actually have to talk about something called a significance level, and so that's what the next video will be about.